The random module is a built-in Python module which allows us to generate random numbers and also perform other random operations on different types of data. Now we can create integers, floats, or even use it on a list to perform certain random operations. And it's very useful when we're building games to create a random behavior of the characters in the game. To get started with the random module, all we need to do is import random. This is an inbuilt library and hence we don't really need to do any installation, and you can just simply say Python and the file name. I'm using something called basic functions. I'll save my file, and when I run it again, it doesn't give me an error, which means that the random module has been found and can be used. So the most commonly used method from the random module is the random.randint function. This number takes two arguments of two integers and generates a random number between the two numbers, including the two numbers specified. This can be used for many purposes, like setting a random speed for a particular ball in a game, or choosing a random amount of time, or specifying a random color, and many other such things. Now let's take a look at how we would actually write this code. Now we already imported random, so all I'm going to do is say number is equal to random.randint, and I will say any number 5, 90. I will print this number to observe the result, and let's take a look. It gives me 16, and every time I run it, it's going to give me a different number. Another random module function that provides us with a random integer is the randrange. Here we can specify two arguments specifying the range, and additionally also specify the step. So for example, if I were to get only even numbers between 0 and 100, I can specify a step of 2. And if I take a look at this number, I will repeatedly see some even numbers between this range. So 0, this time is 32, 90, so on. The next random function we will look at is the random.random. This allows us to generate a decimal number or a floating point number between 0 and 1. Let's take a look at how we would go about this. I'm going to modify what we had earlier with random. Now this does not take any arguments because the limits are already known and they are fixed. And when we try to run this, we get 0.15 and so on, and we can keep running this and it will always give us a number between 0 and 1. The next one we will look at, which involves decimal numbers, is the random.uniform. Now this is like the random.randint, where we specify two numbers between which we get a number, but here it gives us a decimal number. Let's take a look at how we would use this. So I'll change my function that I already have here from random to uniform. Let's do the same example, 10. Let's take a look what we get. You can see you get 6 point something, 8 point something, 7 point something, and so on. So the next method we will look at is the random.choice, and this is the first one that we will learn when it comes to lists. This method allows us to pick a random element from a list that we have. Let's take a look. I'm going to first create a list called fruits. I'm going to say apple, orange, grape, what I'm going to do is going to say the choice is equal to random dot choice. I'm going to pass the list as an argument, and if I print choice, what I should be able to see is a different value that has been chosen each time. First time it's orange, apple, orange again, and so on. The next one we will look at is the random.sample. Now, just like the random.choice allowed us to pick one out of a list, random.sample allows us to specify how many we want to choose out of the list. Let's take a look. So I'm going to modify my code to say sample, and then I can say maybe 2. Let's try here. I get a list of 2 out of the list. Another very useful random function is shuffle. This allows us to shuffle the contents of the list. Let's take a look. Now I'm just going to change this and put the shuffle. I only need one argument of the list in here, and this is going to be the shuffled list as the output. And if I were to take a look at what we get when we do this, has an I spelled mistake. Alright, let's take a look. It gives us this is an interesting one. We got a none. That's because it actually shuffles the list fruits itself and does not return a new shuffled list. This is an important concept for us to know as well. If I take a look, if I print fruits instead, we can see that you have the order that's shuffled, and if I run it again, I will see a different order this time. Now, we're going to look at some advanced techniques in random number generation, and the first one is called random.seed. Now, to understand this, we'll have to understand that a purely random number cannot be generated by a computer because it is based out of some sort of formula or calculation. And these random numbers, even though seem random to us, they're always predictable. That's why they're called pseudo-random numbers. Now, random.seed allows us to get insight into this and is also useful whenever we want a consistent series of random numbers. So I'm going to use random.seed, and I'm going to give, it could be anything really. It just needs it as a source. I'm going to say 10, for example. And now I'm going to generate a set of 10 random numbers. Now, actually, let's make a list of 10 random numbers. Number is equal to num in, I would say random dot int 1, 100 for I in range 10. This is a list comprehension method, and it will create a list of 10 random numbers for us, and we'll print these numbers. And what I want you to observe is without the seed, you will always see different numbers. Let's take a look. I'm going to run this, and I got a bunch of numbers. Now if I run this again, I get the same exact 10 random numbers. It starts at a predictable state. Now if I were to take out this random seed and just comment it out and I run it, I will see that I get different numbers each time. So the random.seed is used as a starting point through which it generates multiple random numbers in a sequence. And that's why when you use a particular seed, you can see that it's always the same set of numbers. So this is why it's called a pseudo-random number, and it's not a truly random number. Alright. So now we're going to take a look at the get state and the set state methods, and these are used to get the internal state of the random number generator, or that gives us randomness in our program. So if you take a look at the example, I make a list and I print it and I get it in its original order. Now I save the list and then shuffle it to see the result being apple, grape, orange, mango. Now, if I were to shuffle it again, I would get a completely different order. But now I'm setting it back to the original, and this time instead of setting this getting the state, I'm setting the state, and now I shuffle the fruits again, and I will get the same exact result as what I had gotten the first time. So this method allows us to save a certain state and get back to it in the order of the random numbers generation. Now, the get random bits method is another unique one which allows us to specify the number of bits that we want for our random number to have. And if you take a look at these examples, when we want a random number with size 8, and I'm going to try to run it, you'll see that it gives us 144. That means 144 is an integer number that can be represented by 8 bits of data. Same way, 16 gives us 24,271. So now we're getting into some of the more complex territories of the random module, and we're going to talk about distributions. Now, the way to understand distributions is not by looking at one random number in itself, but just to understand when you generate a bunch of random numbers to model certain types of data, it will give it to you in a way that shows a certain shape. Now, this is a very common one that we're looking at right now, which is the Gaussian distribution. It's also called the normal distribution. This is used, for example, to model how grades work in a class, and you might have heard your teacher say curving the grade, which means to sort of make it such that there is a bell curve around performance of the entire class, where large number of people are in the middle, a few of them score well, and few of them which may be on the bottom end. Now, if you look at how this works, I'm basically generating 10,000 numbers using the Gauss method. I'm giving it two variables, which is generally called the mean and the standard deviation, and which tells us basically where you want the data to center on and how much of a variation it could have on either side of that center. Now, if you take a look and just plot these numbers, they don't actually give you much insight. So you can see that it's centered around 50 and it can go above or below by a certain amount, and generally around 60% of all numbers are in this part of the data. Now let's take a look. Instead of plotting just the numbers, let's take a look at the histogram. That gives us better insight, and that is what will show us the shape of this distribution. So what you can notice here is this sort of bell shaped, and this is the Gaussian distribution of the 10,000 random numbers that we have generated. Now, similarly, let's take a look at the triangular distribution. Here again, we're going to directly plot the histogram of the 10,000 numbers that we're generating, and what we can see when we run this is basically a triangular distribution. So you have these numbers between 0 and 100, and over the vast number of numbers that we are generating, we see a triangular distribution, right? So this, for example, you could use this to model data like when a movie sort of gets released, how many people go watch it. So we have a lot of people watching up front, and that sort of linearly declines. The next one we will look at is the log normal distribution. Now, this distribution is actually found in many natural phenomena like human behavior, population distribution, income inequality, and many other such things in real life. Basically, the log value of each number has a normal distribution, and you can take a look at this. Each number that's generated, I'm applying a logarithm on it, and what we will see is is a normal distribution of the log values. Now, just like the ones that we have studied, there are many other distributions available in the random module as well. Just going through each one of them, we have the expo variate, we have a beta variate, we have a gamma variate, we have a von Mises variate, and a Pareto variate, and a Weibull variate as well. Now, these are not going to be commonly used by us, so we're not getting into much depth in them, but we will just quickly look at them, and you can look up different data that these are used when modeling certain statistical information. So let's take a look at what we see when we run this. So the first one is the expo variate, and by its name, it's about exponentially declines, and you can also make it exponentially increased by the use of the parameter called the lambda variate. The next one is a beta variate, which can be multiple shaped based on the parameters alpha and beta that you supply. Right now it looks like a normal distribution, not exactly, but by varying the parameters, we can use it to represent certain empirically observed data. So it can also be thought of as a part of a larger distribution. The gamma variate again is similar to the beta variate, where it uses a particular variable called gamma to alter the shape, and again this can be used to model certain parts of larger distributions. Von Mises is another such one, and this has a very specific application, and it's not something that we're going to get into right now, but this is kind of what it looks like. And finally, we have the Pareto variate and the Weibull variate. We're not going to talk too much about their applications because they're sort of part of a larger understanding of statistics, and we'll get to those when we actually get to that concept. And this is the last one called the Weibull, and this is good to know from a Python developer's point of view as what is available, and we will also learn certain applications of all of these as and when it becomes relevant in the future videos. So that is it for the Young Wong's random module video, and I hope you understood and you got something out of it, and we will keep putting in more content similar to this in the coming weeks. Stay tuned. That's me, Sachin, signing off for now. See you in the next video.